Hi, this is Richard C. I'm a math tutor here at Wyzant, answering a question submitted by a student. This student is learning about graphing inequalities, and it looks like pretty soon this same student will be learning how to do something called linear programming, and they're working their way up to that ultimately. This is typically a fairly typical uh, problem that you work on in Algebra 2. So let's just read the problem and set up our inequalities. So every day the store can ship 28 pieces of furniture. So that's one of our inequalities. So we can only ship 28 pieces. So X is number of tables sold plus Y is the number of chairs sold, because they want X to be tables, Y to be chairs. And that has to be less than or equal to 28. And then the other equation is 100 to get $100 for chairs and $3.50 for tables. So Y is chairs. So it's 350x plus 100y, because it's 100 for tables and tables. Oops. X is tables and it's 100 for chairs. Right. So X is tables, they get $350, and Y is chairs, they get $100, and they need to make at least $3,800 in sales. Otherwise, they can't afford to cover their costs. Okay, so what you would do is by hand, you would find a graph for this first equation, which is easy, because when X is 0, Y is 28. When Y is 0, X is 28. Like that, boom, 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 and then you would shade it and shade it below like that. And then you're going to get this other graph, which is going to be much harder to graph by hand, but you can do it. And rather than go through all those steps, I'm going to just import a graph that I prepared. Let's, okay, just take a second. Okay, so here's our graph. We'll just grab it here, make it smaller so we can see it. Okay, so this is the graph. You can see this first equation has the intercepts at 28 and 28. You can see this is the blue. Hopefully you can see the colors here. But it's going to be this line here has an intercept of 28, and then this intercept is 28. So the blue line represents the first inequality, and then the red line represents the second inequality. And the solution region is this sort of purplish looking thing. Now, I always like to indicate the solution region with an R with a circle around it. So there are an infinite number of possible solutions, because any point that lies within the solution region is a possible solution. Let's pick one that's convenient. We'll pick this point. And this is 10, 20, 30. No, it's 20, 40, 50, 60. Let's see, 20, 40, 60, 80, 100, right? So this is going to be 40 here. and 40 here. So this lies within the solution region, 40 comma negative 40. So it'd be 40 comma negative 40, but actually now that I see this, we can't have a solution with you can't make negative. We need another, I see. Okay, sorry about that. We need to put other constraints on this. Obviously, we can't have, there's a third constraint that's not graphed here, which is that the number of chairs and the number of tables has to be either 0 or positive. So there we go. So that is not the solution region. I apologize for that. And so we have to pick a point that is inside the solution region, which is actually going to be this region here. So guessing that's 20, and that's 20, that's 20. So I would say something like 15 comma 5 would work, something like that. That would be a point that lies in the solution region, because that's 20 and that's 20 up here. So this positive 20 comma 20 is this point here. And so we're just going to be 15 over and 5 up, and that'll put us into the solution region. So I'm sorry about that earlier comment about the solution region. And also I want to clean up this. Yeah, because we need x and y to both be positive or 0. So that's a point, any point in there. And obviously, when you put this into your graphing calculator, or you put it into an online grapher, however you do this, or even if you're doing it by hand, you can pick any point in the solution region, which is this little sort of triangular area here, where it's really 4 curves have to intersect here. So we needed this bottom here onto that to make it a triangle. Okay, so that's it for this one. I hope this was helpful to you, and I'll see you again next time. Bye-bye.